In this video, we will explore how to debug Python code using the built-in Python Debugger, also known as PDB. This is a tool that can help to troubleshoot your code effectively. So, what exactly is PDB? It is Python's built-in interactive debugger module. It allows you to pause program execution and inspect variables and the flow of your code. Some of its key features include the ability to set breakpoints in your code, step through the execution line by line, inspect variables at runtime, evaluate expressions in the current context, and also navigate the call stack. There are typically 3 ways to start the PDB debugger. The first method involves using the command line. You can simply type python-mpdb, followed by the name of your script, for example, your_script.py. The second method involves hard-coding a breakpoint directly into your script. To do this, you can insert the line import PDB::PDB, set_trace open parenthesis close parenthesis. The third method, which is available in Python 3.7 and later, involves using the breakpoint function. All you need to do is import PDB, and then insert the breakpoint open parenthesis close parenthesis line where you want to break. You would use the command line method when you want to start debugging from the beginning of the script. The PDB.set_trace or the breakpoint function are used when you want to debug at a specific point in your code. Here are some essential PDB commands to know. Typing H will display help, listing all the available commands. N will proceed to the next line, stepping over function calls. S will step into a function. C will continue the execution of the program until the next breakpoint. Q will quit the debugger. L will list the source code around the current line. P followed by an expression will print the value of that expression. PP followed by an object will print that object, giving a more readable output. B followed by a line number will set a breakpoint at that specified line. W will display the call stack, showing you the sequence of function calls that led to the current point. Stepping through the code is a fundamental debugging technique. Consider this example code where we have a function called calculate_total that calculates the total price of items. To start debugging, you can insert import PDB::PDB, set_trace open parenthesis close parenthesis at the point where you want to start debugging. Once the debugger is active, you can use the following commands to navigate through the code. N, which is next, will execute the current line and stop at the next line in the same function. S, which is step, will step into a function call on the current line. R, which is return, will continue the execution until the current function returns. Finally, C, which is continue, will continue the execution until the next breakpoint is reached. Inspecting variables is a crucial part of debugging. Here are some commands that can help. P will print the value of an expression. PP will print a data structure for better readability. Vars open parenthesis close parenthesis will show all variables in the current scope, and dir open parenthesis close parenthesis will list all the attributes of an object. Consider the example session shown on the slide. Puser_data prints the value of the user data dictionary. PPuser_data prints the same dictionary with a more readable format, and puser_data square bracket items square bracket 1 prints the second item in the items list. Setting breakpoints allows you to pause the execution of your code at specific locations. There are several ways to set breakpoints using the B command. B followed by a line number will set a breakpoint at that line. B followed by a file name : and a line number will set a breakpoint in that file at that line number. B followed by a module name. A function name will break when that function is called. And finally, condition followed by a breakpoint number, and a condition will add a condition to that breakpoint. To manage the breakpoints, you can use the following commands. B or break will set a new breakpoint. CL or clear will clear breakpoints. Disable will temporarily disable a breakpoint. Enable will re-enable a disabled breakpoint, and condition will set a conditional breakpoint. Post-mortem debugging is a powerful technique that allows you to debug a program after it has crashed. This involves entering the debugger at the point of the exception. To use this technique, you can wrap your code in a try-except block, and then call pdb.post_mortem in the except block. Alternatively, you can run your script from the command line with the command Python-mpdb post_mortem py. Post-mortem debugging allows you to inspect the state of your program at the time of the crash. You can access all the variables in the exception frame. You can examine the call stack that led to the error, and you can debug production issues after they occur. PDB allows you to execute any valid Python expression in the current context. For example, you can perform calculations or manipulate strings directly in the debugger. You can also define aliases for common debug commands. Here's how to define a custom debug command. From PDB, import PDB. Then assign a lambda function to pdb.complete. For enhanced debugging, consider using PDB++, which is an extended version of PDB with syntax highlighting, tab completion, and sticky mode. To install it, simply use pip install pdbpp. Finally, PDB also supports remote debugging, which allows you to debug code running in a different process or machine. To use remote debugging, from remote_pdb, import remote PDB. Then call remote PDB open parenthesis, your IP address, port number, close parenthesis .set_trace. Here are some debugging best practices to keep in mind. Always plan your debugging session. Identify what you want to learn before setting breakpoints, and have a clear hypothesis about what might be wrong. Use strategic breakpoints. Set breakpoints at critical decision points in your code, not just where you think the error occurs. Simplify test cases. Create simple test cases that reproduce the problem with minimal complexity to make debugging easier. Finally, write tests for bugs. Once you find a bug, write a test that reproduces it before fixing it to prevent regression issues. Keep in mind, the most effective debugging tool is still careful thought, coupled with judiciously placed print statements. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.